Okay, so as the next part of this unit, we're going to take a little trip back to Algebra 1 and freshen up some of those skills that we learned way back when. They're skills that are going to help us with these quadratics. So turn to page 55 in your workbook, and you'll see that part A talks about multiplying these two binomials together. Now, I don't necessarily like the notation that they use in the book. You're certainly free to follow your way through the book and use their notation. For me, though, I think what most of us have gotten accustomed to when multiplying a binomial times a binomial is doing FOIL. And FOIL stands for first, outside, inside, last. And when we use FOIL, essentially, we're going to multiply two terms by two terms and get four terms. And then we're going to combine like terms. Okay? So here we go. The F stands for first, and that means the first term in each of those binomials. X times x is x squared. The O means outside, so the outermost terms. That's going to be these out here, the very outermost terms. X times 5 is just 5x. The I stands for the innermost terms, or the inside terms. That would be these two right here. 2 times x is 2x. And then the L stands for last, which would be the last terms. 2 times 5 is 10. So basically, you're just doing the distributive property 4 times, and everything needs to be multiplied by everything else. So now it comes down to a fact of, okay, now that I've done that, let me go ahead and combine any like terms that I see. Well, remember, in order to have like terms, we need to have same variable, same exponents. So here I see a 5x, positive 5x, and here I see a positive 2x. They both have a variable of x, and that exponent is 1 for both of those. We cannot combine those with the x squared because that has a different exponent. So now when I put this all together, I have an x squared, and then when I combine 5x plus 2x, that gives me a 7x, and then that plus 10 can't be combined with anything. I'm going to bring that down, and I'm left with this trinomial. So x plus 2 times x plus 5 is the same thing as x squared plus 7x plus 10. We haven't done any work to solve anything. All we've simply done is write that in a different form. Now, let's undo that. Let's do the opposite of multiplying, which is factoring. Okay? Now, I have to think that multiplying is going to be something that you guys are going to get reaccustomed to a little bit quicker maybe than factoring, because factoring tends to be a little bit more difficult. So let's talk about how we can factor x squared minus 3x minus 4. So if you go back to the previous example, essentially we are going to go from this form, and I'm going to head back up here and try to come up with something like that. So multiplying and factoring are the opposite thing. Now I have this trinomial, and I would like to eventually turn this thing into, if I can scroll down, a binomial times a binomial. Okay? So in short, here's what we have. The standard form for a quadratic looks like this. ax squared plus bx plus c. That's nothing new. Okay? In this case, if there's no coefficient in front of the x squared, it is assumed to be a 1. If it is, that is good. We like that. These are easier to factor when the number in front of the x squared is a 1. If it's anything else, things get more difficult. But for now, let's just stick to that. Okay? Essentially, what we're looking to do here is we want to find two numbers that add to give me negative 3 and multiply to give me negative 4. So to do that, I'm going to come over here and I'm going to say, okay, let's come up with a list of two numbers that multiply to give me negative 4. Well, I have negative 1 times 4. I have negative 2 times 2, or the reverse of that, but that would be the same thing. And I have 1 times negative 4. Those are the three pairs that would multiply to give me negative 4. Okay, so for each of these, the question then becomes, what do those add to give me? Well, negative 1 times 4 is plus 4 is a positive 3. Negative 2 plus 2 is a 0. And 1 plus negative 4 is a negative 3. The pair that I'm looking for here is the pair that add to give me negative 3. So that's going to be this pair right here. Because of that, when I do my double bubble, I know that it's going to be x times x because that's what gives me x squared. And I'm going to use positive 1 and negative 4. It does not matter what order you put those. You could put the minus 4, then the plus 1, doesn't matter. So that x plus 1 times x minus 4 is the factored form of x squared plus 3x minus 4. So if indeed you did FOIL this out like we did on the previous slide, it would FOIL right back to where we started. So FOILing and multiplying sort of undo each other. They're inverses of each other. Now real quickly before we finish this up, I want to give you a little calculator trick to look for factors. Alright, so let's say that you had a number that you were looking for factors of, say like number negative 72. Let's say it was x squared minus, I don't know, 12x minus 72, something like that. Okay, and you don't want to list out all the factors that give you negative 72 because there's a lot of them, right? Grab your graphing calculator. So in your graphing calculator, if you're wanting to find factors of negative 72, there's a trick so that we can go to the table and see all of those factors. So hopefully now you can see my graphing calculator on your screen. What you'll want to do is you want to go to your y equals in the upper left hand corner, and whatever the number is that you want to know factors of, in this case negative 72, you're going to go ahead and put in negative 72 divided by x. And you know that x is the button below mode. So whatever the number is, you're going to put in front of that divided by x. So if you want factors of 16, you do 16 divided by x. If you want factors of 50, you do 50 divided by x. And now you go to the table. So second graph. And now this table gives you all the pairs that multiply to give you negative 72. You can see where this may take you a while if you were listing all these out by hand. The reason this can be useful is that if I go back to my slide, now I'm looking for a pair that add to give me negative 12. Okay, so instead of listing out all those factors, I can just go to my calculator and I'm looking for a difference of negative 12. Now I may not even find it because I just made this up off the top of my head, but you can see where the value in this is. You're just looking for the pair that add to give you negative 12. I'm not sure that I see it, so this may not be factorable. Okay, so there's a little shortcut. We'll get used to doing that in class. When you're looking for factors, go to your calculator, put in that third number, whatever it is, divided by x, and then go to the table, and that'll give you factors of that number. Because remember, when we factor, it all comes down to two numbers that add to give me the first number and multiply to give me the third number, or add to give you the second number, multiply to give you the third.